This is video number 4 in the topic around indices, or more specifically indices and scientific notation. And in this video we're going to do a little bit of revision of something that you should have seen previously in school before National 5, which is changing numbers back and forward between scientific notation and normal decimal form. So just to remind you that you will have seen this before, scientific notation, which we sometimes call standard form, is just a quick way of writing very large and very small numbers. Numbers in scientific notation are written in a very particular way. The form that they have to take is this: a times 10 to the power of b, and in this case a is just a number between 1 and 10. Now it has to be between 1 and 10, so if it's any other way, this won't be considered correct scientific notation. And b has to be an integer. It will be a positive integer if we're dealing with very large numbers, and it will be a negative integer when we are dealing with very small numbers. So let's look at how we would change this first number, 357,000,000, or 35.7 million, into scientific notation. So here's our number, 357,000,000. If I want to change that into scientific notation, I have to give myself to begin with a number between 1 and 10, which is based on this. So I start with 3.57 will be the basis of my scientific notation number, and it will be times 10 to the power of something. Now note that I've used 3.57 here. I can't use 35.7 or 357. It has to be between 1 and 10. So in this number, 35,700,000, there is a decimal point here, and it's right here. There'll be a 0.0 there if you like. To get the decimal point back to here, it has to move. So we talk about just counting the jumps as being the most simple way of doing this. So it's moved 1, 2, 3 times. 1, 2, 3 more. And a final time to get to here where I've put it. So in order for me to make this work, the 7 becomes our power of 10. So that number written in scientific notation would be 3.57 times 10 to the power of 7. Okay, shouldn't have done that. Blanked the page by accident. So the next example we have is, here we have 7.32 times 10 to the power of 8, and I want to change that into a normal number. So I want to do what I previously did in reverse. So I am going to begin 7.32, so my number has to have 7, 3, 2 involved. In my scientific notation, the decimal point was here, and I want to move the decimal point to the end of the number just to get a normal number if I can, and I have to move it 8 times. Move it once, twice. Now I've run out of space, but I want to keep track of the jumps here. 3 times, 4 times, 5 times, 6 times, 7 times, and 8 times. We use a particular number in maths as a placeholder, that's the number 0. So we just have to fill in any gaps up to that decimal point with a 0. So what I now have is this number 732,000,000, or 732 million. What we're now looking at in the 2 examples below that is very, very small numbers. I have 0.00005,215. and I'm going to change that into a scientific notation number. So let's write it out just to keep track of what we're doing. 0.00005215. Now, in scientific notation, we have a number between 1 and 10. Based on this, so in this case that's going to be 5.215 times 10. Now, because this is a very small number, we're going to have a negative power, but we have to work out negative what exactly. In our number, here's our decimal point. I have moved it and I want the decimal point to be here, so I have to keep track of how many jumps I have made. Well, I've moved once, twice, 3 times, 4 times, 5 times, 6 times. So that's 5.215 times 10 to the power of negative 6. So if I was filling in the table, 5.215 multiplied by 10 to the minus 6. And last of all, we'll look at doing that the other way around. We are going to be changing a small number in scientific notation into its decimal form. So I have 1.31 multiplied by 10 to the negative 5, and that is going to be equal to something. I don't quite know how big that number is going to be, so I'm going to leave myself some space, and I'm going to start with 1 and 3 and 1, because I know they'll be in my final answer because of the 1.31. In scientific notation, the decimal point is here, and it's a negative 5, so that is then going to have to jump 5 times to go back to where it was. So 1, 2, 3, 4, 5 times. I've not left quite enough room, but that's okay. I have to then fill in my placeholders, so I have a 0 here, a 0 here, a 0 here, a 0 here. My decimal point has moved to here, so that means I also need another 0 to placehold. So that number would be 0.000013. That's conversion between normal and scientific notation. In a moment we will look at the last video in this series where we'll talk about doing calculations using numbers in scientific notation.